We're looking today at day 4 notes. We're going to continue with just 3 example problems of how they can test your understanding of continuity in just a little bit different way than what we looked at in yesterday's notes. So take a look at this piecewise function. Our top function here is going to be 5x plus b. So right away we see something different with a variable b, or a constant b, sorry. So here's what they'll give you this setup. First off, don't panic just because we see x's and b's. They do this a lot on the AP Calc exam. They're going to tell you that b is a constant. They're going to say what value of b makes f of x congruent at x, congruent, makes f of x continuous at x equals 3. We're going to say what value b makes f continuous at x equals 3. What I want you to do is pause the video right now, and I want you to think to yourself, how in the world could we possibly solve this problem? I'll come back with the explanation in a second after you've thought about it, maybe tried it, maybe not. Okay, for a function to be continuous at a point, in this case the point x equals 3, we need to have the left-hand limit and the right-hand limit equal to each other. So the limit exists. Once the limit exists, then the function has to be defined at that point, and those two have to equal each other. But the majority of the work here will be done in proving or making sure that the right-hand limit equals the left-hand limit. So what I'm going to say down here is limit x goes to 3 minus of f of x must equal limit as x goes to 3 plus. That's what we know. That's what we have to prove first to show that the limit exists. Okay? So we're gonna set this up as the left-hand limit equals the right-hand limit. Okay? Obviously, if those two equal each other, we know that the function is defined because we see that little equal sign right up here. We see x is greater than or equal to 3. So we know the function is going to be defined, and this whole thing will end up being continuous. But this is what we have to ensure to be true. So again, when we look back up here, we need the limit as x goes to 3 minus to equal the limit as x goes to 3 plus. Left-hand limit equals right-hand limit. So let's just plug in, and we'll leave b alone, and we're going to end up solving for b. So here's what this is going to look like. The limit as x goes to 3 minus, for the left-hand limit, I need to use the function 5x plus b, because that's where x is less than 3. So what I'm going to do is I'm going to calculate the left-hand limit at 3. And that would be 5x, but the x we're letting equal 3, plus b. And we don't know what b is yet, but that's okay. That's what we're trying to solve for. That will be the left-hand limit. Now that left-hand limit has to equal the right-hand limit. We want to use the other function for the right-hand limit. The right-hand limit at 3 will look like this. It's x squared plus 2, but we're calculating this limit at 3. So we can just say 3 squared plus 2. Right now we have one equation with one unknown, so we can solve. We're going to end up with 15 plus b equals 9 plus 2. So we're going to end up with a value of b equaling -4. That means if b equals -4, that turns our top function into 5x minus 4. And 5x minus 4 and x squared plus 2 in a piecewise with 3 as our split will give us a nice continuous function. One thing I want to show you quickly on the calculator is how we graph piecewise functions. I knew about this a while ago, but I had to look up on somebody else's video how to do this. Okay, but we can graph this piecewise function now with our answer to see if this thing is actually continuous. So to graph a piecewise function, just go ahead and put your first function in parentheses. Well, our first function is 5x. It ended up being -4 because we got -4 for our b value. Close the parentheses and put another set of parentheses opening up. And we can, what we want to do is we want to set this for x less than 3. So we want to set the parameters. So we say x. Notice right here on the math button written in blue is test. We can hit second test. That'll allow us to choose our less than sign. We can see it's number 5. X less than 3. Close it. We also want to add in our other function. So the syntax on this calculator is you have to hit plus. And I'll just type in the other function, which was x squared plus 2. Make sure that function is in parentheses. And then after, we're going to open another set of parentheses and say x. We're going to do our test. That was for x greater than or equal to 3. So that's number 4. And close it. Now when we graph this thing, it will graph the piecewise function. We can't really see it here. I'm going to make my y max a little bit bigger so I can see what's going on here. Let's make this maybe 25. And what we see here is the piecewise function, and we can see that this thing is continuous. When x was less than 3, our function was linear, 5x minus 4. So we can see on this part of the graph here, a linear function of 5x minus 4. You can see the y-intercept of -4 there with a slope of 5. But once we hit an x value of 3, it switches to the function x squared plus 2. That's why this line starts to curve, because it's a quadratic. Okay, but we can see that they do line up, and we can see that it works. Okay. I'm going to do 2 more examples here. And again, I'm going to set the example, and then I'm going to I want you to pause it, give yourself a chance to solve it on your own. Our next question is this. Here's our function. And we got 4ax plus 3 when x is less than or equal to 2. And we have -2x squared minus 1 for x greater than 2. By the way, for that last problem, before you start solving this, that b equals -4, that allows us to show that the limit exists. The function would also be defined there, and they would equal each other. So we would pass all 3 tests, but on a multiple choice, once you show that the limit exists, and 3 is included in one of these 2, then we know we're good to go. So let's take a look at this one. Go ahead and pause the video now. Try solving it, thinking about it the same way we did on the last problem. Okay, we're back. Once again, I want to set my left-hand limit equal, left-hand limb, I want to set that equal to my right-hand limb as x goes to 2 from the left side and the right side. Okay. We're going to be able to plug in for the variable x because we know our limits are at 2. Okay, we just have to choose which one correctly, plug them in, and solve for a. When we do this here, we are going to have 4a times x. Our left-hand limit, we're using x less than or equal to 2. Our x value is 2. So we have 4a times 2 plus 3. That has to equal our right-hand limit. We're going to use the x greater than 2 for that. So we're going to say negative 2 times our x value, which is 2, squared, minus 1. Solving this thing out, we end up with 8a plus 3 equals 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. We're going to subtract 3 from both sides. We get 8a equals negative 12. We end up with a equals negative 12 over 8, which reduces to negative 3/2. So on an AP multiple choice, they might say again, the prompt of the question is, what value a makes this function continuous at x equals 2? For it to be continuous, the limit has to exist, the function must be defined, and the limit must equal the function. That value of negative 3/2 makes the limit exist. The function would also be defined at that same point, so we can move on from there. Okay. One last example and we'll be done, hopefully a lot quicker than yesterday. Take a look at this setup, f of x. We got 2x plus 3 on top for x less than 1. We've got ln x plus c, x greater than or equal to 1. So again, I want to choose what value for c makes f continuous. Now, what point do you think I'm going to be asking about continuity at? First one I asked 3, the second one I asked 2. This one, the place where the piecewise splits is at the value 1. So again, I want to make sure to make f continuous. I want to make f continuous at x equals 1. That means the limit as x goes to 1 minus of f must equal the limit as x goes to 1 plus of f. Go ahead and pause this video right now and work it out. Okay, welcome back. Let's see how you did this. Let's see how I did it, and see if we can make this thing work. So what I want to do now is I want to plug 1 into my left part of the function, which is 2x plus 3. So I'm going to have 2 times 1 plus 3. That must equal the right-hand limit, which will be ln of 1 plus c. Now the left side of the equation here simplifies very nicely. We get 2 plus 3 is 5. We need to know the value of ln1. This is ln of a number is always just a constant. ln1 is one that we have to know. Okay, think back to your pre-calc log work. Right? E raised to what power gives you a value of 1? E to the 0 would equal 1. ln1 always equals 0. So we get 0 plus c, so we know that c equals 5. Again, c equals 5 confirms that the limit exists, right? And gives us a value of 5. To show that the function is defined, again, because 1 is in our domain here, we could plug in and we get 5. So the limit equals 5, the function equals 5. The limit and the function equal, therefore a c equals 5 gives us a continuous function f at the value x equals 1. Thanks for watching. Always remember, subscribe. Talk to you later, guys.